Okay, Assalamualaikum warahmatullahi wabarakatuh and good day to all of the panels. My name is Wan Jaslan bin Wan Jaafar. I am supervised by Dr. Rahimah binti Abdul Hamid during my bachelor's degree project. So my title for my bachelor's degree project is a surface topography study of the untreated and heat-treated zirconia dental crowns manufactured through CNC dental milling machine. The introduction CAD-CAM milling machine milling system in the dental field enables zirconia ceramics to be used as a standard material for dental restorations and simultaneously accelerating the process of creating restorations. The untreated CNC mill restorations, however, exhibits moderate surface roughness due to the reflective deflection between the cutter and the workpiece during the milling restoration process. Surface roughness is one of the main properties which is responsible for the microbial attractiveness of denture surface. Therefore, in this study, the surface roughness of the untreated and heat-treated CNC mill zirconia restorations were examined using SEM machines. So basically, there are many types of restorations in the dentistry industry, such as you can see in figure 1 shows the bridge restorations and figure 2 shows the crowns restoration. So for my study, I will focus on the crown restoration only. The first hypothesis of this study is there will be some scratch grooves and also scallop high effect which could be accounted on the untreated restorations. The dental crown would be heat treated in order to improve its surface texture, but the appropriate temperature is still unknown. The second hypothesis of this study is there will be an improvement of the surface roughness of the dental crown after the heat treatment. A study on the surface topography of the untreated and heat-treated dental crown was carried out. So the measurement process was challenging due to the complex geometrical of the dental restoration surface. So the first objective of my study is to compare the surface topography of the untreated and heat-treated zirconia dental crowns using the scanning electron microscope machine. The second one is to analyze the surface roughness of the untreated and heat-treated dental crown using appropriate surface roughness tester. So there are a few scopes for my study. One of them is an existing CAD file of the dental crown was directly used to fabricate the specimens. The scanning of crown is not carried out due to the limitation of capable 3D printer, 3D scanner in UTM. So one of my limitation during my study is the instrument of the surface roughness tester does not provide the actual measurement of the crown surface restorations due to the limitation of the machine capability. For my methodology, you can see in my flowchart, my project was started with the 3D virtual model in CAD and then generate the STL file, continued with the milling process of the zirconia dental crown, and then after that, we fabricate the part which is 12 specimen of the crowns. Continue with the several tests, which is the first is heat treatment, second is surface roughness measurement, and lastly, the microstructure analysis. During the study, there are 9 samples need to be heated, which is 3 replication at each temperature. The other 3 samples is untreated sample. So firstly, for the dental crown specimen, which is the sample preparation, we decide to fabricate 12 samples of zirconia crown restoration, 3 samples for untreated and 9 samples for heat-treated crown. For heat treatment, we use 3 temperature settings. First, for untreated, we have 3 samples. 2 samples we will use for surface roughness measurement and 1 sample for SEM analysis. Second, for heat treatment, we have 3 replication at each temperature setting. 2 samples we will use for the surface roughness and 1 sample for SEM analysis. So next, we move to the zirconia dental restoration milling process. As you can see in figure 4, this is the Adenta 3D dental milling machine that we use during my study to fabricate 12 samples of dental restoration. During this process, the work material used is Next ZRT, which is obtained from Sage Max Bioceramics. So for your information, after we purchasing these zirconia blocks, as shown in figure 5, the Sage Max Bioceramics give us a few samples of CAD file for the crowns and bridge restoration. So we just need to select one of them, of the sample that provided. So we move to the heat treatment test, which is carried out using the machine that provided using the furnace that provided by FKP. So this heat treatment was conducted after mill restoration. So we decided to use three different temperature, which is 850, 950, and 1050 degrees Celsius. So each temperature we test by 3 replication of crown sample. We use 3 replication because to avoid the human error. For the machine parameter setting, we use from the other researcher, such as the waiting time, heating rate, final temperature, and the holding time. So after we finish the heat treatment, the selected sample will be conducted for surface roughness test using Meteoto Surf Test SJ410 that provided by FKP Lab, as you can see in figure 7. The selected sample is 2 from untreated sample and 2 sample from each temperature setting that hit earlier. Before we starting the test, we need to performing the calibration, which is adjusting the detector gain so the SJ410 can yield correct measurement. Then the specified point was selected at the buccal and the lingual at each sample. We decide to select 4 points at each side of the sample, as you can see in figure 8. The measurement areas that have been selected is in consideration with the limitation of the surface roughness tester, which is could only read the flat surface. In this context, the measurement was repeated 5 times at each selected point to yield correct average measurement and to avoid possible error during measurement. After we finish the roughness test, all of the selected sample need to be coated with gold sputtered using the mini sputter coat provided by FKP. This process is required in the field of electron microscopy to enable or improve the imaging of the samples. So for the last process, which is surface topography analysis, we conduct and analyze this test using the SM machine that provided by FKP. The topography or the surface texture of the untreated and heat-treated crown was examined. 1 sample from each condition was selected. For the SEM parameter setting, we also take from from other researcher. So we move to the result and discussion. During the fabrication of the crown, a design was selected, as you can see in figure 12. The selection of the crown design was made because it has a flat surface texture compared to the other design. So the measurement of during the surface roughness test will be easy. There are a few parameter settings that need to be adjusted, which is number 1 is thickness and diameter of the stock. Number 2 is material of the stock. Number 3, type of crown that need to be machined, and lastly is number of support. The critical test setting is the support structure. As you can see in the figure 13, the number of support structure will affect the surface of the crown. During the machining, the time taken to manufacture a crown is 40 to 50 minutes due to the brittleness feature of zirconia. The zirconia block is attached to the material platform and locked, as you can see in the figure 14. The feed rate and the spindle speed is automatically generated by Adenta. After finish the machining, all of the samples need to be wrapped to avoid crack since they are very brittle. So for heat treatment test, a few parameter settings need to be adjusted, such as waiting time, heating time, final temperature, and holding time. So a time taken to reach at the desired temperature is around 17 to 21 minutes for all of the samples. 2 samples from each temperature were examined using surface roughness tester. Sample that was measured for surface roughness were not examined during the SEM because the surface of the samples contains some scratch due to the stylus tip. 1 sample from each condition is analyzed in SEM machine. So for the critical and critical result, which is the surface roughness analysis, the measurement was taken at each side of the samples. The selected measurement area is because they have wide and quiet flat surfaces, which is easy to measure. During the apparatus setup, there was a problem occur where the sample moved from the current position when the stylus tip start to take the measurement. The use of plasticine is required to remain the position of the sample, as you can see in figure 16. The result from the roughness measurement is taken. The comparison between untreated and heat-treated samples is shown below. So as you can see in the table, the results indicates that the heat treatment does not improve the surface of the zirconia crown. The average measurement of at point D of sample 1, which is untreated sample, is same with the temperature same with the 1050 degrees Celsius heat treated, which is 0.6 millimeter. This is happen because the instrument does not provide the actual measurement of the surface roughness due to the limitation of the machine capability. In addition, the sample does not provide flat surface. So there are some error occur during the measurement of sample 8 caused by also by the limitation of the instruments. So the lastly is the surface topography analysis. So one sample from each condition was examined using the SAM machine to support the result from the surface roughness measurement. As the outcome of the SAM, the scallop height effect are seen in the image with 50 power magnification for untreated and heat-treated crowns. This is due to the final temperature used. The gap for all temperature used is too close where we can see the effect of the heat treatment. The temperature need to be higher than 1200 degrees Celsius. So as you can see in figure 17, the image show the scallop height effect after the outcome of the restoration. And then the figure 18 shows the scallop height effect still exists after the heat treatment of 1050 degrees Celsius. So in the conclusion that can be drawn from this study is, the first one is the temperature of 850 degrees Celsius, 950 degrees Celsius, and 1050 degrees Celsius does not improve the surface roughness of the zirconia dental crowns. Second one is the surface roughness instrument plays a significant role to measure the crown's surface. And the last one is the standing electron microscope analysis of the crown samples prove that heat treatment of 850, 950, and 1050 degrees Celsius does not affect the surface of the crowns. This reflects the second objective of this work. So there are a few recommendations were drawn for the future study. The first one is 4 samples for each condition to ensure the measurement taken is valid and to reduce measurement error. Second one is the furnace should be more advanced in parameter setting. The current furnace used does not have the cooling rate parameter. The third one is the temperature used must be in the range of 1030, 1300 and 1500 degrees Celsius. A recommendation by other studies used in this study did not exhibit a good result. Therefore, for the selection of temperature in the next study, the use of phase diagram is proposed. A true check of the composition of the zirconia has to be conducted in order to obtain an accurate heating temperature. This is because the use of zirconia by other researchers could vary in terms of the material composition. The selection of suitable profilometer must be considered in order to get a good result in roughness measurement. The one we use in the metrology lab is only capable to take a flat reading of samples. That's all from me. Thank you for all of the panels for spending time watching my video. So thank you again. Assalamualaikum warahmatullahi wabarakatuh and have a nice day.